What I'll do now is to talk about COAT and the ecological condition of Arctic tundra, because we have used in 2021, we've used the data that we've collected through the ecosystem-based monitoring to do the first panel-based assessment of ecosystem condition in low and high Arctic tundra. Next. So I'll give you a short walk through the first operational assessment of ecological condition of high Arctic tundra. And it's also a little bit about low Arctic because we also deal with Finnmark, the low Arctic tundra. But I'll focus mainly on the high Arctic. This work is based on the ecosystem monitoring that's facilitated by the implemented research infrastructure that we've done the past 5 years and the long-term monitoring efforts by various from center institutions. Next. Just a small reminder, just you know, and I've said it many times, we are at the core of the SIOS land module. We are from base, so it's a consortium, and we are led by NPI, the COAT Svalbard. And mainly we build and expand the ongoing long-term monitoring of the tundra ecosystem. And here again is the figure with the tundra ecosystem and with all the different various SIOS instruments that feeds into monitoring of the tundra ecosystem and feeds into the ecosystem-based monitoring that we do. And those are the data that we've used for this assessment. Next. So in 2021, I and the Norwegian Polar Institute was asked by the Norwegian Environment Agency to do the first operational assessment of ecological condition of both high and low Arctic tundra based on a panel-based assessment method. And this assessment should serve as a tool for development of ecosystem-based management strategies and actions in both low and high Arctic tundra ecosystems. And the data we have collected in the ecosystem-based framework is necessary to do such large-scale assessments of ecosystems. So this was mandated and asked from the Norwegian Environmental Agency that need this kind of information based on the ecosystem or the ecosystem monitoring data that we collect. Next. We collected a scientific panel FRAM-based with various institutions from the FRAM Center consisting of myself, the Norwegian Polar Institute, the University of Tromsø, NINA, MET, and also with experts from Aarhus University, which is part of the COAT consortium. Next. So to do this work, we had a framework that was developed back in 2017, which is called the System for Assessment of Ecological Conditions. And this applies to all kinds of Norwegian ecosystems. And mainly it reflects 7 structural and functional ecosystem characteristics. Next. So when I talk about ecosystem characteristics that characterize an ecosystem and common for all ecosystems, including the Arctic tundra, it spans from primary production, landscape ecological patterns, biodiversity, functional groups, abiotic conditions, which are main drivers of Arctic ecosystems, and so forth. So each of these indicators were evaluated according to these characteristics. I'll get back to that quite soon. Next. So what we did was that based on the definition said in this fagsystem that you see on the side here, it was defined what is an intact ecosystem state. Of course, that can be debated and discussed, but we had to adhere to this definition that says it's characterized by the maintenance of the fundamental ecosystem structures, functions, and productivity. So that was the ecosystem reference stage. And then we used a reference climate, which is described for the climatic normal period from 61 to 90. And we're already way beyond that, and we will see that quite soon. Next. So the process is a hierarchy. It's a 4-level assessment based on the scientific knowledge base. So we have the knowledge base, And then we have indicators. So the indicators rest upon the extent to which expected change in indicators are supported by evidence of observed changes. So we have expected changes, phenomena, and we have observed changes in indicators that we see through the monitoring data. And then this is evaluated in the context of the indicator itself up to the ecosystem characteristics and to the ecosystem as a whole. And it's all based on statistical analysis of estimation of change rates in indicators. Next. There is a published protocol for it, so we strictly follow the protocol that's inspired by the same kind of working methods that, for instance, the IPPC panel is using when they do their large-scale assessments. Next. And the assessment of Norwegian Arctic tundra is considering Svalbard. You can do the next, please. The tundra in Finnmark, including the forest tundra ecotone and the easternmost low Arctic peninsulas in Finnmark. Next. And then the tundra in Svalbard, which is covering a much, much larger spatial extent than in Finnmark. So the coverage of data was quite different between the two regions. The coverage is much better in Finnmark than in Svalbard in general when it comes to spatial replicates and spatial extent. Next. So the indicators, they measure ecological condition. So it's based on 34 data sets, and we had 16 shared indicators between the two systems, 26 unique to low Arctic and 8 unique to high Arctic. Next. The indicators are mainly species or functional groups, characteristics for Arctic ecosystem, species that are endemic, and also indicators that are from the abiotic conditions that are the main drivers of changes in this ecosystem that is under human pressure, particularly from climate change. Next. So the key findings from the assessment, I'll try to summarize just very briefly the overall condition of both ecosystems, and then I will do a bit more in detail on Svalbard. Next. So the Norwegian Arctic tundra have since the climatic reference period undergone rapid and substantial changes in the abiotic conditions that we all already know. And it's particularly manifested as increasing surface temperatures, longer and warmer growing seasons, shortening of the snow-covered season, and increasing permafrost temperatures. Next. However, despite this, it seems like the biotic changes are still kind of lagging a little bit behind. And we see the largest change rates are in indicators with strong causal links to climate. It could be characteristic Arctic species or endemics, meaning that some of these species are disappearing, and particularly the ecosystem in Finnmark is going from being tundra to becoming more boreal. And we will see the same type of development further north, but we are lagging naturally, of course, behind still. Next. So what happens on the Svalbard tundra? I'll give a few more details on that from the report. Next. If you look at the ecosystem characteristics, the landscape ecological patterns, we see really large changes in Arctic zones. If you look at the graph up to the left, we see the division of Arctic subzones back in 1961 to 1990. And then you can look at the lower one, right graph, where you see that there's a really shift in subzones. It's becoming in general warmer. This is based on July temperature. And of course, this will have implication for both the growing seasons or growing conditions and also for the herbivores. Next. When we look at the ecosystem characteristic abiotic factors is where we find the really major changes. And they go all from winter melt days, amount of precipitation, snow cover extent, temperatures, and permafrost. So there are major changes that do impact the rest of the ecosystem in various ways. And that's all described in detail in the report. I will not go through it now, but it's just to show you that there are major changes. Next. Despite these major changes, we also see that the functionally important species here, with the figure showing the number of reindeer on the upper, the dense with the Arctic fox, the number of geese and the number of ptarmigan on the lower panels. These populations, they increase have increased quite a lot during the time period, or they show more stable population development as the shared predator, the Arctic fox. So despite these major changes in abiotic factors, many of the resident and migratory populations, they do quite well. Next. So if we look at both systems, trying to summarize as a conclusion for the ecosystem as a whole, then we have gone through the hierarchy of evaluations and we try to sum the results for the ecosystem. Both the low and the high Arctic ecosystems are overall in good ecological conditions, with fundamental structure and functions still maintained despite substantial changes in the abiotic factors. And in the report, we have strictly followed the protocol, and you will also see definitions. So when you say good ecological conditions, that means that the main fundamental structures and functions are still maintained. Next. But some biotic ecosystem characteristics do show deviations from the reference conditions, while others are presently also on significant change trajectories, which should be considered as a warning of more extensive changes in the ecosystems. And this particularly is pertinent to the low Arctic tundra, where we have loss of Arctic endemics, we have loss of lemming cycles, we have an ecosystem that moves towards a more boreal system, and with time, the low Arctic will be lost in Norway. And we expect that same type of changes when we go into the next 21st century will also take place in Svalbard, but still it seems like responses are lagging, which is good. Next. We have in the last SES report given a summary of both the status of the terrestrial ecosystem and also the key conclusions of this report. So please, if you want to read more, you can go there, or you can actually download the reports and read in detail what is happening with the Arctic ecosystems in Norway. I think that was the last one. Thank you.